Good afternoon. My name is Ryan Bast, and I'll be conducting this presentation on ergonomics in industrial environments. Just a quick reminder for everyone to silence their cell phones, and I did enclose at the back of the room some supporting documentation for this presentation, so feel free to grab some right now if you haven't already done that, or to use that for reference if you wish to do so. So on the agenda for this workshop, I'll speak to you about who is the Motor Safety Association, some WCB Ergonomic industry statistics, and our strategic plan when it comes to ergonomics. But the main highlights of the presentation will be the industrial ergonomic case study, so some very specific examples of different things we've taken on to look at ergonomics and improvements in an industrial environment, and we'll have some questions and answers at the end if time permits. So what we see here is these are my reasons to be safe. This is my family, my 2-year-old son Carson, that's my daughter Bailey. That picture is taken just on the night before her first day of school. What's also exciting is in about a month we're expecting our third child, so we're seeing a lot of different changes in our family, and it's an exciting time for us. But when I look at that picture, those are the reasons that I try to be safe every day in the workplace and at home. So a little bit about who is the Motor Safety Association. So we are a provincial safety association that are non-government and non-profit. So we aren't OSHA or WCB or Occupational Health and Safety. So we're not the regulators. We assist with safety issues. We help people with claims management and return to work. We do ergonomic assessments, inspections, audits, and various training workshops, which we do highlight those on our website. So we are set up in the province of Saskatchewan. For those of you who don't know where Saskatchewan is, I've put a map here, and you can see we're kind of in the middle of Canada. Saskatchewan is a population of approximately 1.1 million people, and out of that 1.1 million people, 409,000 are working. So out of that group, 30,000 of those people that are working fall under the Motor Safety Association, or 13.6% of all the working population in Saskatchewan would fall under our association. So we have about 4,000 companies and about 30,000 employees that fall under our association. So Saskatchewan, the size of it is much the same as the similar land mass to what Texas is, and our economy is very similar. We are a resource-based economy. We do a lot as far as our resources is oil, gas, agriculture, and mining. And as you can see on the right-hand side of the screen, we're on Twitter, so feel free to check us out on there if you haven't already done so. So within these 4,000 businesses that fall under our association, this would be a sampling of all of the WCB rate codes that would fall under our group to give you a better picture of the industries we service. So you can see by this list that the people that fall under our group are doing a lot of the grunting work, a lot of the heavy duty and the lifting, and they're exposed to those ergonomic injuries. So we do see those concerns quite frequently. To validate how frequently we see them, we looked at our WCB stats over the last 5 years, and as you can see, 27.5% of all WCB claims are attributed to ergonomic injuries within our industry. That makes up 48.1% of our costs and 54.2% of all of our WCB days lost. So we have a problem here. Ergonomics are really driving a lot of our costs and our days lost within our industry. Interesting to add to this, in the last 5 years, people have missed just about 75,000 days of work within our industry due to an ergonomic injury. So there are a lot of different concerns that have been risen from these claims and different ways of reducing the injury from happening. So some of the challenges that we would face every day, or we would try to come to different businesses and offer them some help and say, hey, we're here from the Motor Safety Association to give you some assistance on how to minimize these costs. But a lot of times people, they wonder, well, what is the catch? How much is this going to cost us? So those are some barriers that we have to overcome. And people sometimes aren't understanding what exactly ergonomics is. They think it's simply just adjusting the office chair or having their computer monitor set up correctly, and that is a component of office ergonomics. But in the industrial environment, we're looking at that material handling and different aspects of that. So we are trying to have that education aspect out there. And not being able to have access to management is a big one. Sometimes we can't get past reception at some of these various businesses, or in some situations a business owner or manager may own half a dozen gas bars, and he may be from out of province or from a different sector, and it's hard to track down the decision makers. So those are some of the challenges that we face in improving these ergonomic stats. So what we did to accomplish this was we developed a 3-year ergonomic plan, and our plan was to educate and empower companies to make these ergonomic improvements with them. We didn't want to create 30,000 ergonomists. That would have been great, but it wasn't realistic. We want to get the people talking about ergonomics, and us working with them to complete the assessments, or if they want to do them on their own, that's great as well. So we're trying to educate people on ergonomics. And the 3 points to our plan included offering an industrial ergonomic workshop. So this is a half-day workshop. It's fun. There's a lot of industry-specific examples, success stories, videos, and we feature some of these case studies on our website as well. But with this workshop, we get the people out there, and it's creating that awareness. They're talking about ergonomics. And before we get them to the workshop, we invite them. So we come out to various communities and different sectors, and we can tell which businesses are having those ergonomic claims. And just simply a task as inviting someone to a workshop about ergonomics gets that conversation started. And sometimes that's enough to get the ball rolling. So right now we are just about completing year 1 of this ergonomic plan. Our goal was to reduce ergonomic claims from 27.5% to 20% by 2016 year end. So we'll know more at the end of this calendar year how we fared with year 1. To get into some of the specific industrial case studies for ergonomics that we have taken on, this will carry on probably the most part of our presentation this afternoon. So specifically, I'm going to start out with tow truck operators. So we've, as mentioned before, we have all of the stats for when it comes to the different injuries and sectors within the business. And in this specific example, a discomfort survey was used with this towing truck operator company, and they determined that they were suffering a lot of back pain and strain on the shoulders. And through observation, lifting steel dollies, as shown in this picture, was a task that created that strain. And as you can see, each set of steel dollies weighs 78.4 pounds a set. This had a NIOSH lift index of 4.3, and you're going to hear me refer to the NIOSH lift index throughout the presentation. We were earmarking a lift index of 3 or greater as an extreme level of risk, so anytime we can get it less than 3, we've been doing better with it. So this is the task at hand, and upon assessment, some of the things that we found could be done differently were looking at, well, why are we using these dollies in the first place? If we dispatch the flat deck truck, as seen on the bottom left-hand picture, we're going to get away from having to even utilize the dollies. The disadvantage of that is it costs $35 more per trip, so we do have that cost factor built into it. But what about if we didn't use steel dollies? They actually make aluminum dollies, and they're about $25 less per set, and they have a NIOSH lift index of 2.7. And as you can see, they weigh 48 pounds a set, so they are lighter. And those were a couple of different controls that could be used to reduce that hazard for the dollies on the tow trucks. What about moving 600-pound barrels of antifreezes for customers? So if a business such as this one, they sell bulk product by the barrel, and they're moving about 12 barrels in an 8-hour shift. So they are moving these quite frequently. We used a push-pull gauge to determine it takes about 120 pounds of force to tip that barrel and to get the momentum going. And so there was some repetition and some risk involved with this task. What would make this better, like most ergonomic fixes, would be engineering controls. If we had the opportunity to use a mechanical lift or a different setup to utilize it so we could do it mechanically, would be our best bet. Sometimes due to budget or space requirements, these aren't practical. And sometimes in this environment, they ended up utilizing a worker rotation or 2 workers to do this task, just because of in their storage shed, they weren't able to use one of these 2 devices for moving these barrels of product. But while we were on site at this same bulk fuel dealer, they mentioned the concern they've had with delivering bulk oil and bulk fuel to customers. And what happens is they have an 1.5-inch hose that's 20 feet long. So they got to grab that hose, pull it up at least another 20 feet, then up an 8-foot ladder. So you can see the force required to pull that hose and to keep that hose moving. And it was repetitive. They're doing this 20 times in an 8-hour shift. This is the person's job. They are a delivery driver of bulk fuel. So it is highly repetitive, not to mention the risk of trying to climb a ladder and remain 3 points of contact while doing this, especially with an aging workforce that were doing this task. So what they ended up doing was we looked at the tables by Snook and Sorello, and the majority of the male industrial population would not find this task as stressful, so it would be within their capabilities to do that. However, we wanted to bring them something forward that we could do to make it better. So they looked at utilizing a motorized hose reel, and this allows the operator to extend or retract the hose, and they don't have that initial pull and that sustained pull to get that hose moving. So that was a great way of getting the hose out without having to put that large of a pull on it. But it still had the problem of climbing the ladder to fill the tanks. So the opportunity to use ground level tanks was presented, and this dealer embraced it. He said he was all for it, and he didn't want his customers or his employees climbing up these tanks to fill them. So he offered his dealer cost with financing to give people the best deal possible to purchase these tanks. So in the long run, it's allowing his own employees to not to be exposed to that risk of climbing those ladders carrying the hose. So that worked out quite well for that business and their customers. So next, I'm going to talk about the combine concave case study. For those of you who don't know, the concave is on the bottom right-hand side of the screen. Each concave weighs about 88 pounds, and there's 3 of these per machine. It's a task that you have to remove and replace these, and it's in a hard-to-reach area, and it causes exertion and back strain. But instead of me explaining it further, I'll show you a short video of our findings. Okay, so that covers off that assessment and gives some good explanation of what we've completed for it. So on that same combine, changing the tires on the combine, they have a NIOSH lift index of 9.1. And myself, growing up on the farm, with my personal experience, I know this is a tough task. A lot of times now these machines have duals, or some of the times tractors have triples, and they're tippy and they're very awkward to maneuver. So we looked at different ways of utilizing this. Here's an example of an engineering control, was this wheel mover jack. You would bring it up around the wheel and you can lift it up, and it allows you to move it. The limitation to this device is the terrain. If you're not on a smooth floor, it's going to be very hard to use it. So you wouldn't be able to use something like this in a gravel or outdoor environment. Looking at the shipping receiving department of a business, so a crate of parts comes in, as you see in the picture, and they're stooped over, unloading these parts. It's very repetitive. That's what a shipper and receiver does this job constantly. They're moving these parts in and out of the box and into the bin locations. So this task does take a lot of time, and they have an awkward posture, and they're doing this job constantly. To make this task better, actually we found some quite inexpensive controls. If we lifted that pallet up and we had a pallet rotator, we can elevate it so we don't have that stooped posture, or something as simply as tilting the pallet allows you to get the parts and minimize that reach. So those are a couple of fixes that won't take a lot of time or money to complete. We next looked at lifting commercial tires into dunk tanks. So large tires, these ones are about 70, 80 pounds a assembly, and at this business they're lifting these tires into a dunk tank of water to check for leaks, and when it's leaking it's going to bubble in the water. So there's a lot of awkward posture, initial force to lift that tire assembly, and they were doing this once an hour, and these are quite heavy tires that they're conducting this with. So we looked at this project and thought, well, why bring the tire to the water if we can bring the water to the tire? So if we set this tire up over the floor grate and used a water bottle or a garden hose and were able to put water on it, it would eliminate the need for that lift. But what this business ended up doing was they had a steel beam overhead of where this dunk tank was located, and they utilized this beam and an electric winch, and they were able to complete this task, and they were able to do it at a very low cost as far as the equipment purchase, which helped them so much in minimizing those risks to back injuries. At another tire business, this business was tasked with selling to their customer commercial tires, and they needed to be stacked 74 inches high on a pallet or 7 tires high. And this had a NIOSH lift index of 5.7. And we did some discomfort surveys with this business, and they indicated that stacking and lifting these tires did cause major strain on their back and shoulders, and it was a tough task for them to do. It was highly repetitive, 720 tires per week, excessive reach, awkward posture. This was a task that is challenging to do. I actually have a short video here that shows them doing this task. So you can see it is 5 tires high, and it's already up to the person's head. So they had to put these tires up to 7 tires high. And the reason for that was the customer, or the end user of these tires, due to logistics, they needed them stacked a certain way on a certain pallet. So they were supplying this pallet that they needed them stacked to this height. A better option would have been perhaps stacking the tires 4 high and putting another pallet on top of that pallet with a forklift, and so you would be essentially 8 tires high, but you're using twice as many pallets. That would have brought the NIOSH lift index down as well. There's different devices such as this here crate where you roll the tires into them, but it's 720 tires a week. This wasn't an option either for cost and the space requirements that it would take up. And this business wasn't interested in using an overhead winch to do it because of the costs associated with the extra time it would take to do this task. So we found some different scenarios for this business, and unfortunately, to our frustration, they didn't implement any of these controls, and this business was suffering from those back injuries and shoulder injuries. And it was concerning. Management was aware of the injuries, but were more concerned with getting the product out. So that was a struggle that we sometimes face because we're not regulators. We can't stop them from doing this. We can only provide them with the information to make it better. Looking at another task here of, say for example, in a tire shop where you have the vehicles up on a hoist and you're removing and replacing tires all the time. So you take the tires off, you may be doing a brake job or getting into work on that front components of the vehicle. So to take the wheel off and lower it to the ground and raise it, you're constantly going up and down with these tires. And you do this enough times, and we know some of the vehicles, for example, the big trucks, these tires are getting a lot larger. So some different components of making this task better was the person ended up using a temporary hanger to put onto the hoist. And he welded foldable pins right onto the hoist to allow temporary access to hang the tire and wheel assembly. So therefore, instead of, once that tire and wheel assembly is removed from the vehicle, they don't have to lift it up and down. They just basically take it off and hang it right beside them. So that brought the NIOSH lift index greatly down to 1.7. It reduced that vertical travel distance. I just want to advise for you not to weld anything onto your vehicle hoist, as it may infect the integrity of the hoist. You can contact your manufacturer or get permission before you weld anything onto the hoist. And we do show a feature of this in the supporting documentation that I brought that shows the actual device this person used. And another positive spin-off of using this device was it reduced that clutter and trip hazards on the floor, which is very positive as well. Another task we looked at within a seed plant that sells bags of seed. They have pallets of these bags of seed, and when they're trying to maneuver that pallet or move it, it initially takes 93 pounds of pull to get that task, or to get that pallet jack moving. And this study was conducted on a level concrete floor. We looked at the Snook and Sorello tables, and only 50% of the male population could safely perform this task, and 10% of the female population could safely perform this task. So we knew that some sort of control needed to be brought into place. Because of the posture, the repetitiveness, and the different strains and risks involved with conducting this sort of work. So obviously the best way to complete this would be mechanically, if we were able to bring in some sort of a motorized pallet jack. Or that would work great as a great alternative. If you don't have access to that or a limited budget, you could reduce the load, have less. But in this situation, these pallets are shrink wrapped with a certain amount of product on it, so you couldn't reduce the load. They actually looked at reducing friction by changing the wheels on the pallet jack, and this study was conducted a few years ago, and since this time, there's a lot of good suppliers that the engineering of these wheels have come a long ways, and there's so many different products out there that are a lot better than the original ones that came with the pallet jack as far as the wheels. So that was an opportunity. They actually looked at, because this assessment was conducted on a concrete floor, they actually put a piece of tin down in the area that they were working, and this tin actually brought the initial force down from 67 pounds to 93 pounds. And that was the venue that they went down as in the short term, until in the long term they were able to purchase a motorized pallet jack. So that's what they had conducted at their place of business. But I do want to advise, though, if you do something like this and you do put tin down, be careful, because you may have created another hazard. This may be a slippery surface. So just keep in mind when you try to fix something that you don't create another concern. The last one that we conducted, and was probably a major project for us, was a hand-arm vibration study, where we looked at the hand-arm vibration, which was causing tingling, numbness in white fingers, and loss of grip strength. So we ended up looking at different ways we can minimize this hand-arm vibration. We utilized a hand-arm vibration monitor, which you can't really see. It's hose clamped under this person's hand on this picture in order to measure the vibration. And our goal was to look at some cost-effective solutions of reducing these hand-arm vibration hazards. So there's a video of the actual demonstration of when this process was recorded, and this person was using a 1-inch pneumatic impact wrench to remove those lug nuts. And from the results of this test, so a worker using this tool for an 8-hour average would be exposed to 25.197 meters per second squared of vibration. This was quite high. In the graph, when we see a lot of bumps and high values, we have concerns. The exposure limit value was 5 meters per second squared, and that was basically the limit of what the person should be you can't be exposed to in the day. And in this situation, if they did this task for 11 minutes, they would reach that value. The EAV is the exposure action value, and that is basically the daily amount of vibration in which the employer is required to take action to control it. And that's at 2.5 meters per second squared. So we were well above those values, and we needed to find something to bring those vibration levels down for the users of these impact wrenches. So we did some exploring and hunting, and we sourced an anti-vibration wrap. And this is basically a foam wrap that adheses to the handle on various tools. So this was put onto the handle of the 1-inch impact wrench, and then we were, with this in place, we ended up conducting the same test under the same conditions. And to our results that we see on this graph, as mentioned before, less bumps are good. The 8-hour average was 0.9175, which made a big difference. And looking at our averages for the exposure limit value or exposure action value, we're way below that. So utilizing something as simple as this vibration wrap or this foam that we put onto the handles of the impact greatly reduced that person's exposure to vibration, which was made it quite comfortable for the end user to use. What's interesting, in our province, OSHA, or Occupational Health and Safety, or in the United States, OSHA, our local Occupational Health and Safety Division have actually been writing notices of contravention or citing employers if they aren't using this foam or anti-vibration wrap to minimize the vibration exposure. So they took a close look at this study, recognized the value in it, and when they see people not utilizing this sort of a wrap, they look at it closely and cite businesses for those infractions. Another thing to mention, with this business, I ended up coming back a year later after this product was in place for a follow-up, and as you see in the picture, there was a lot of, it was a dirty environment within a service shop, and this vibration wrap with the oil and grease, it was still effective. We measured the values a year later, and they didn't change a lot as far as the effectiveness of the wrap. So over time, this wrap still remained effective, and feedback from the users were they were very happy with it. It didn't affect the way they had used the tool. It was still, it didn't cause any negative comfort to them, so they were quite satisfied with the results of this. And since then, we've been promoting this, and it is mentioned in the that supporting documentation I provided as well. So where do we go from here? After we've looked at these different assessments at our Safety Association, we're going to remain true to our ergonomic goals. We are in year 1 of our 3-year plan, and we're going to keep creating that awareness, getting people out to our workshops, getting the conversation started around ergonomics. It is hard to measure some of those results, as we've seen in the Concave study. For example, farmers that may be using those on their farm, we can't measure those results for reducing ergonomic injuries because we specifically look at the businesses that I featured earlier in the presentation as within our group, so we can't measure those results. But we are going to be very proactive when we get out to these shops and businesses, when we conduct inspections. And we're going to talk to them about ergonomics, talk about some of the risks involved, and looking at controls, talking to workers, getting their buy-in and feedback is critical. So many times the workers, they have the answers. They just need someone to facilitate the discussion, recognize the risk, look at the controls, and promote and sell that to management in creating those environments where we can foster effective relief to these ergonomic injuries. So therefore, that concludes the presentation this afternoon on ergonomics in industrial environments. If you do have any questions, you feel free to contact myself anytime. My email address is on the screen, as well as my phone number, as well as our Twitter feed. So feel free to contact us if you do have any questions. Thank you.